Here we have the integral of 7 cosine squared times sine of 4x. Let's look at a couple of options for what we might choose for our u. If we chose sine of 4x as our u, then differentiating would give us du equals 4 cosine of 4x. That extra 4 coming from the chain rule. Now you know that whenever you pick a u for your integral, your du better show up in the integral. And we have a cosine squared here. That's not exactly cosine of 4x. Maybe we could make that work, but I'm kind of questioning it. If we choose instead u equals cosine of 4x, then differentiating would give us negative 4 sine of 4x. And then what does our integral turn into? Well, we have this cosine squared of 4x here. That's just u squared. Then we have a sine of 4x dx that appears right here in the integral. So it looks like what we could do is divide both sides by negative 4, and then that would turn this sine of 4x dx into a negative 1/4 du. So this substitution seems to work pretty smoothly. We're not going to do this one, and let's see what happens. I'll pull the 7 out. We'll talk about the limits in a second. We get u squared, as we said before, times a negative 1/4 du. We can pull that negative 1/4 out of the integral, and now maybe is a good time to discuss limits. Let's use a technique from the last video where we take our limits on x and turn each of them into a limit on u. To do that, we use our u-substitution. So when x equals 0, u is cosine of 0, which is just 1. When x equals pi, u equals cosine of 4 pi. And cosine of 4 pi is also 1. Well, that was pretty unexpected. We got a lower limit on our integral of 1 and an upper limit of 1 as well. We could go through the motions and actually do this integral, but we know what the answer is going to be. We know that if we have the same lower and upper limit here, it doesn't matter what this antiderivative is, we are just going to get 0 as our answer. So cool, that was pretty fun. Let's do another one.